All right, let's take a look at what we have here. So what are we going to do to solve A? Do you have a calculator?
So I already did the first one.
Okay.
So number 2.
Okay.
And yes, I do have a calculator.
Okay. Let me take a snapshot of this. What 3 things are happening with this function compared to this function?
So
differs by 3 things, right? The 2, the +1, and the -3.
right.
So let's talk about what each one means. What does the 2 mean? Let's go from left to right always.
Okay. So it's a vertical stretch of 2.
Correct. Which means if the original, let me put the original up there, that's square root of x, then a vertical stretch would be skinnier. In other words, everything is 2 times as much. So every point we have on the red line is going to be 2 times higher on the blue line. So this blue line would be 2 root x. Okay. Now what's the +1 do?
It's shifted left 1.
Okay, good. So we take our blue curve, doesn't change the shape. It's merely a horizontal shift of 1 unit. So it's going to look essentially parallel to the blue line. Okay, and that is 2 root that. Finally, we have 1/3 thing. What is that?
It's shifted down 3.
Okay, so we take this point right here, we move it down 3. Again, it does not change the shape. It only changes the lateral shift or the vertical shift, one or the other. And so this might look like that. And that's the way you want to do all of these. Okay, let's talk about the domain and range. What is the domain of the f of x? We graphed it already, so we don't need to do that. Let's talk about its domain and range.
So
Domain refers to which variable?
The x.
Correct, always. So you could figure it out without the graph, but let's see if we can figure it out with the graph. If you look at the graph, what's the domain? You want to train your eyes to look horizontally only. In other words, what are the allowable values for x?
0 to infinity.
Correct. 0 need a parentheses or a bracket?
A bracket.
Because you can take the square root of 0. Okay. What's the range? Again, you can look at the graph. Now look vertically. what are the allowable values for f of x?
Zero or negative infinity? Or
Look at the
no.
graph. Train yourself to figure these out either algebraically by looking at that or graphically. If I'm looking up and down here, what are the allowable values that you see on that graph for f of x?
0 and infinity?
Yep, same two. Okay, now let's look at g of x. And this time, let's not look at the graph of it to figure it out.
Okay.
When you're talking about domain, you're basically talking about what can x not be. It is usually what the answer, that's the way you have to think about domain. It's not so much what x can be, but what can x not be. Well, if you look at g of x, how am I to restrict x? What's true? You can't take radicals of negative numbers, correct?
Right.
Okay, so what does x plus 1 have to be? That's what can't be negative, correct?
Yes.
It's not the x. It's whatever's inside the radical sign is what can't be negative. So what is true about x plus 1? Correct?
Oh, yeah.
Okay, now solve that inequality for x.
So, x is greater than negative 1.
Greater than or equal to.
Greater than.
Okay, so that's
Right. Yeah. Oh, yeah.
in other words, we know x has to be greater than or equal to negative 1. It could actually be negative 1. Notice that if it's negative 1, you're taking the square root of 0. Well, you can do that. Okay. Now, if I put that in interval notation, what is it?
Zero.
First of all,
Negative or
C's or a bracket?
bracket.
Left bracket. Okay.
And then negative 1. And then infinity?
Uh-huh. There's no upper limit on x. X could be a million, x could be a billion, x could be a trillion. Okay. The limit is on the lower end of it. It cannot be negative 2. Because if it were negative 2, we'd be taking the square root of negative 1. And you can't take the square root of negative numbers. Okay. Now, let's think about the range.
Okay.
When we're talking about g of x, we don't, again, this isn't going to affect it. That might affect it. What primarily is going to affect it is that. What does that have to be? What does the square root of x plus 1 have to be? Positive or negative?
Positive.
Always. Square root of x, that's always positive. It's Square root of x plus 1 is always positive. Anytime you take the square root of anything, you're going to get a positive answer. Okay? So 2 times a positive number is still a positive number. However, x could be minus 1, so this could be 0. What's the smallest amount that, hold on a minute, what's the smallest possible number that can be?
0.
Okay, so what is the smallest possible number that can be?
Negative infinity?
No, negative 3. In other words, if this inner circle can be 0, well, 0 minus 3 is minus 3. So g of x can be minus 3. If you remember when we drew that curve, it looked something like this. Well, guess what that is? That's at minus 3. Because we shifted the whole thing down by minus 3. So, and you do use interval notation, correct?
Yeah.
Okay, good. So in interval notation, what is the range going to be? And give me bracket and parentheses, left bracket, right bracket, things like that.
Okay. So, left parenthesis.
Well, we'll leave it up in the air for the moment. What number are you going to put in there?
Negative 3.
Now, can it be negative 3?
Yeah.
Then that's not a parentheses, that's a bracket.
Okay.
That's the difference between a bracket and a parentheses. If it's a
Okay.
parentheses, it cannot be that. And all infinities have parentheses because infinity is not a number. It's a concept. Just means growth without bound. So it automatically has a parentheses whenever you see either a negative infinity or a positive infinity. It goes after the comma here. Look at my graph. Vertically.
Infinity?
Uh-huh. And when I say look vertically, that's not easy to do because notice what this thing is doing. It's going almost horizontal, okay? So it's not easy to look vertically at that. But what you have to realize is that if I go far enough to the right, it goes up always. So if I keep going to the right, it keeps going up, which means it does not have an upper limit. It can go to infinity.
Okay.
Okay. And we figured that one out without really looking at the graph. We just figured it out algebraically.
Right.
And you want to be able to do it both ways. And the reason is that you won't always have a graph. In other words, they might give you these two functions and just say, well, tell me the domain and range of each one of them. And you wouldn't want to have to graph it. So you want to be able to figure them out algebraically for sure. Okay, number 3 is pretty much the same thing, only a little different function. Number 3, the function is the cube root function, which looks like that. Okay. In other words, that is y equal cube root of x.
Okay.
Okay. That's this function there. Now, we got two things only that are happening. What are they?
So, shifted right 4.
Okay, let's do that. So this point right there where it's going to go through, there's a shift of right to 4 units, and it should not change the shape of the graph. Some of these transformations change the shape. When you have shifts and shrinks and reflections, you might change the shape of the graph. But when you have vertical or horizontal shifts, I think I said shift twice. I meant when you have stretches and shrinks and reflections, you change the shape. But when you have shifts only, whether they're horizontal or vertical, it does not change the shape. Okay.
Okay.
What else? What's the other thing happening?
Shifted up 5.
Up by 5. So I'm going to put my blue curve again, no change in shape. But so I'm going to try to draw a parallel curve to the blue curve, only shift it up by 5. Okay, so our green curve is this function right there. Now, look at the red curve. Tell me its domain and range. That's f of x.
So the domain is
Look horizontally.
so bracket, left bracket.
How far to the left can it go?
Oh, negative infinity.
Okay, how far to the right can it go?
Infinity.
Is there any place on that curve where it cannot be? Can it be 0?
Yeah.
Okay, then the domain is all real numbers. Okay, now let's look at range for f of x. Now you have to look vertically. And this is a little tricky. A lot of people have trouble shifting their viewpoint to strictly a vertical look.
Okay.
How far down can it go?
Negative infinity.
How far up can it go?
Infinity.
Yeah, even though it's not obvious by looking at that red line, because it almost looks like there could be a horizontal asymptote there. But if you look at the algebraic function, well, if you take the cube root of 1,000, you get 10. If you take the cube root of 1,000,000,000, you get like 10,000. So if I make x big enough, then the cube root of x still goes to infinity. So it still goes all the way down to infinity, and it still goes all the way up to infinity. Whether I'm looking at the graph or the function. Actually easier to see on this one by looking at the function, because you can experiment. You can plug in certain numbers. In other words, are there any numbers that give this problem? Can you take the cube root of -8?
Yes.
What is it?
2.
It's -2.
Oh.
It's not plus or minus.
Is okay.
-2. The reason is that -2 times -2 times -2 equals -8. That's always how you figure it out, basically. In other words, whatever you come up with, when you multiply that number by itself 3 times, you better get what was inside. So we can take the cube root of all negative numbers. We can take the cube root of 0. We can take the cube root of all positive numbers. What's the cube root of positive 8?
2.
Correct. Whenever you take odd roots, cubes are odd, you only get a plus or a minus. When you take even roots, you always get both. If I'm solving this problem here, my answer, I've got to take the square root of both sides. That is plus or minus 2. Because -2 times -2 is +4. And +2 times +2 is +4. So when you're taking even roots, you get a plus or minus answer. When you're taking odd roots, you get the sign of whatever the sign inside the radical sign is.
Okay.
It's the domain on g of x. Now, g of x is my green line. So you can look at the function and figure it out, or you can look at the graph and figure it out. How far to the left can you go? Look at the
negative.
How far to the right can you go?
Infinity.
And is there any number that you can't put in there? In other words, is there any number that creates problems, like division by 0 or taking the square root of a negative number? No, there aren't. In other words, the transformation, g of x, has exactly the same domain as f of x did, because there's no restriction when you take cube roots. You can take cube roots of plus or minus numbers. About the range?
So is it also negative infinity and infinity?
In other words, again, you're looking at the green curve vertically. It goes all the way down to negative infinity, and it goes all the way up to positive infinity. Even though it doesn't necessarily look like it, when you look at the curve, it's not obvious that that's the case. But that is the case. All right.
Okay.
Guess that's a negative sign in front of there, huh? Work me through number 4 step by step.
Okay.
You don't need to tell me what you're going to do. Just tell me what the next line is.
So -1/2 x to the third equals 108.
And the next line. What's the next step going to be? Tell me the step here also.
So divide by negative 1/2.
Yeah, that's hard to do though. Isn't it easier to multiply by negative 2?
Yeah.
I know a lot of students do this. Let's just talk about this for a second. First of all, that is exactly the same as this. The difference is you tend to look at this and think of it as a multiplier. It's a multiplier by 1/2, therefore I'm going to divide by 1/2. Whereas when you look at it over here, it's being divided by 2. Therefore, I'm going to multiply by 2. Now,
Okay.
dividing by 1/2 is the same as multiplying by 2. So you're not doing anything different. It's just a little bit of a different way to look at it where you don't have to worry about fractions. In other words, would you rather have this problem? 108 times 2 or 108 divided by 1/2?
108 times 2.
Yeah, I think most people would agree they'd rather face that one, even though most students will realize that that's the same thing. Okay, so what's the next line?
So,
In other words, I'm going to
negative.
multiply both sides by -2, right? Because I want to get rid of that negative sign also. In other words, I'm whittling away at everything that is with the x cubed. My final line is going to be x equal. So I got to get rid of everything. I got to get rid of the negative sign. I got to get rid of the 1/2. I do it by multiplying by 2. So the next negative 2. So the next line is what?
X equals negative 216.
Now what's the next thing to do?
Cube root negative 216.
So x equals the cube root of negative 216, which is
6.
negative 6.
Negative 6.
When you're taking odd roots of negative numbers, the answer is always the same sign as whatever the sign is in the radical. So it's negative 6. Now,
Okay.
I'm guessing you did that in your head, not on your calculator. Because had you done it on your calculator, you would have gotten negative 6. What kind of calculator do you use, Dimitri?
It's like an older version of a Texas Instrument.
Okay.
I got this one.
And you know how to take the cube root of numbers?
Yeah.
Like that. In other words, you take the number in parentheses, put that little arrow, and when you take it to the 1/3 exponent, that's the same as taking the cube root of it. If you're trying to take the square root of something, you can take it to the 1/2. Although your calculator probably has a square root key, right?
Yeah.
But it doesn't have a cube root key, is my guess.
Well, I can do like the cube root or fourth root or any of that. The x or nth root, I can do that on this.
Oh, okay. It's still worth knowing that cube root's the same as an exponent of 1/3.
Right. Yeah.
Okay. Number 5, step by step.
So,
read the next line.
So the third root of 4x minus 5 equals
Go ahead.
2 or 3.
And the next line.
4x minus 5 equals 1.
Hold on. Let me rewrite this because I fear I've confused you a little bit by the way I've written it. Okay, so there was our second line.
Right.
How do I get rid of that radical sign?
Oh, multiply by 3, or the third. Multiply to the third.
It's not multiplication that we're doing. It's exponentiation. That's higher than multiplication. You go addition, multiplication, exponentiation. Okay, so we're not multiplying this. We're cubing both sides.
Right.
So when I
That's
cube
what.
the left side, I get 4x minus 5. When I cube the right side, what do you get?
So 27.
Okay. In other words, you weren't multiplying by 3, you were cubing it. And then I trust you know the rest.
Yeah.
All right.
So, yeah.
Okay, number 6. A little different. First step. Tell me what the first step's going to be.
So, square both sides.
Good. Now tell me what the next line is.
3x plus 1 equals, in parentheses, x minus 1 squared.
Go ahead and do that. In other words, you're right. That's exactly what it is. But now I got to do the next line. And the next line is getting rid of those parentheses. And in order to get rid of those parentheses, I got to actually do it, square that. So what's the next line?
So 3x plus 1 equals x squared minus 2x plus 1.
Good. Now the next line. Well, first of all, immediately, what can I do?
Subtract 1.
Correct. That gets rid of that one and that one. Now what? Now I got this. I got 3x equals x squared minus 2x. How do I solve that?
Divide by 3.
No. It's important to know what you're looking at here. Is this linear?
No.
What is it? What's it called? It's quadratic.
Oh, yeah.
So how do you typically solve quadratics?
You have to equal it to 0.
Exactly. You got to get everything on one side and the other side's 0. So which side am I going to put everything on?
The right.
Correct. Because I want this coefficient in front of the x squared to be positive. I don't want it to be negative. So I don't want to really bring what's on the right to the left. I want to take what's on the left and move it to the right. So what does that give me?
X squared minus 6x.
Subtracting 3x from both sides. I'm not multiplying. I'm not dividing. I'm moving the entire 3x to the right side. The way I do that is by subtracting 3x from both sides. What's minus 2x minus 3x? Minus 2 minus 3. What's that?
-6.
Do it on your calculator.
Oh my god. -5x.
Okay. I wanted to make sure you could do it on your calculator because some of the older calculators, that's not that easy to do. In other words, does the calculator you have both a subtraction sign and a separate key for a negative number?
Yeah.
And that's the way you'd have to do this in the calculator. You'd have to hit the negative key, then 2, and then the subtraction sign, and 3. Whereas if you have one of these dinky calculators like I got on my desk right now, it only got a subtraction sign. And I can't do subtract 2, subtract 3. It does not give me subtract 5, or it doesn't give me -5. So you got to be a little careful doing that on a calculator, depending on what kind of calculator you're using. But clearly you shouldn't need a calculator to do that problem. You had it in your head, you were going to do multiplication, and you couldn't think of any other thing. All right, now what's the next step? I got everything equal to 0, now what?
So um hmm. Greatest common factor?
Yeah, actually that's true. I was going to say always be thinking factoring. When you're dealing with a quadratic, most of the time you should be thinking factoring. Now, it might be a normal quadratic that would have a constant, in which case you'd have to factor it into 2 linear factors, but that's not the case here. There's no constant. So all I can do is factor out a greatest common factor, which gives me what?
X times x minus 5.
Which gives me what are my 2 solutions? Got 2 things multiplying together to equal 0. Set both of them equal to 0 and solve.
So x is 0.
It's one solution.
And x is 5.
Okay. Now, whenever you have a problem that has a radical sign in it, it's very likely to have extraneous solutions. In other words, both of these solutions don't have to be true. The rule for algebra merely says is that when you have 2 things multiplied together equaling 0, one of them has to be 0. Doesn't say both of them have to be 0. We usually set both of them equal to 0 and solve, but it doesn't have to be that way. Now, so since there's such a high likelihood of extraneous solutions, you need to plug both of these solutions in and see if they both work. So take 0 and plug it in. Does that work?
No. Or
No, you're right.
yes.
It doesn't. No, it doesn't.
Is
Square root of 1 is not equal to -1. So that one we're going to cross off. That's extraneous. As long as we're doing it, let's try 5. Does 5 work? What's the left side of the equation equal to when you plug in 5 for x?
4.
What's the right side?
Oh, wait. So 16. So the square root of 16 equals 4.
Okay. And the right side equals 4. So x equal 5 works just fine. And that is the only solution for this problem. X equal 5. Notice that it wasn't that easy to get. When you have square roots in equations, they're always a little hard because they always turn into quadratics, which means you end up with two solutions. Usually one of the solutions doesn't work. So there's a lot of steps to that problem. And you have to square that properly, which a lot of people don't. Half my students would have said x squared minus 1. You didn't. You squared it properly.
Okay.
You know how to do number 7? Or would you be allowed to use a calculator if you were taking a test on these?
Yes.
You sure?
Mm-hmm.
Okay.
Yeah, I think at least.
I don't think you want to use a calculator on this problem because it's going to give you irrational numbers and there's going to be round off error. And you're not going to actually come up with the right integer. There's some principles. It says using the properties of rational exponents and radicals. Well, there's a property here involved. If I have the fourth root of A times the fourth root of B, what's that equal to? Down here.
AB to the 1/4.
Yeah, it equals the fourth root of AB. In other words, we have different bases, but the same exponent. So whenever you have different bases and the same exponent, you multiply or divide the bases, whatever is called for, and leave the exponent the same. So what are we going to end up wanting to take the fourth root of?
3,750.
Now go ahead and do that on your calculator because I don't know how to do that by hand.
Okay. 3,750.
Gotta think that that's a whole number, although that's going to be hard to do.
It's a decimal. It's 7.8254229.
I don't think they want a decimal answer here. I think the answer they want to see is this. Because it says simplify, which doesn't mean turn it into an approximation. It means give an exact answer. That's an exact answer. The decimal you gave me was an approximation. In other words, the test here is not to come up with a number. The test is to simplify. That's what we're trying to do, is figuring out how to use the properties of exponents and radicals to simplify that. And it simplifies, quite frankly, as what I just wrote. Okay, let's do the same thing on 3.
So it's the third root of negative 64.
That we can turn into a whole number. Surprised they gave you this one like that. In other words, we couldn't simplify that beyond what we did. Well, I might have actually been able to simplify it if I could find perfect fourths, but I don't think they wanted you to do that either. However, this one is a small whole number. What is the small whole number?
2, I think.
2 cubed is 8. 3 cubed is 27. 4 cubed is 64. So what's the answer?
4.
No.
-4.
Odd root. Whenever you're taking an odd root, the answer always has the same sign as whatever's inside there. -4.
Okay.
Okay. Let's do 9.
So, divided by 3. It's the 5th root of 256.
What is that in your calculator? Is that 2? That's not 2. 2 to the 5th is 32. It's not 3. It might be 4 to the... No? That's his... That's his... Okay. Is that a decimal also?
Yeah.
Okay. Let's talk about simplifying this, because we actually can simplify this.
Okay.
In the same way, let's talk about simplifying stuff. Okay. If I say take the square root of 40, I can break that up into the square root of 10 times the square root of 4, and then that becomes 2. So your answer becomes 2 root 10. And my whole goal was to find 2 factors of 40, one of which was a perfect square number. Now, can we do that with this number? Can I find a factor of 256 that is not a perfect square number, but it's a perfect fifth number? What's 2 to the 5th? Good
32.
Yeah, it's good to know your 2's. Now divide. I happen to know that 32 goes into that a whole number of times. How many times?
8.
Okay. So this becomes the 5th root of 32 times the 5th root of 8, right? Now, I can't simplify that anymore, but I can simplify the 5th root of 32. It's 2. So it's 2 5th root of 8. And this is the answer that you should get. In other words, this is simplifying this radical all the way down. Now, if I go back over to this problem here, number 7, and I say to myself, can I factor 3750 and have one of the factors be a perfect fourth number? Well, 2 to the fourth is 16. Does that thing divide evenly by 16? 3750? Doubt it.
No.
Okay. Let's think of other perfect fourth numbers. 60. No, let's see. 3 to the fourth is 81. Does that thing divide by 81?
Hold on. No.
And the only other one that it could maybe be would be 4 to the fourth, which is the same as 8 squared. So 4, oh, hold on a second. No, it isn't. 4 to the fourth is 256. So does 3750 divide by 256?
No.
At that point, I'm going to give up, and I'm just going to go with that answer. In other words, I'm going to assume that I cannot break that down further. As opposed to the fifth root of 256, the only reason I knew I could break that down is because if you count up by twos, you go 2, 4, 8, 16, 32, 64, 128, 256. So I knew that I could write that as a factor of 2. That's 2 to the 7th or 8th power. And so I knew I had to be able to divide that by one of those perfect fifth numbers. 32 is a perfect fifth number.
Okay.
All right, let's do 10. It's different. It's the easiest thing to do for starters on 10.
Simplify the inside stuff.
Okay, what does it simplify to?
So the third root of a to the sixth.
You're just subtracting exponents. Okay.
B to the seventh. C to the 10th.
Okay. Now what's the cube root of a to the 6th?
Sixth is 8.
A squared.
Oh.
A squared times a squared times a squared equals a to the 6th. So when you're taking roots like this, what you're really doing is dividing with exponents. You're dividing 6 by 3. Okay? So I'm going to take that entire a to the 6th out. Okay, now what does b become? What's the cube root of b to the 7th?
B squared comes out.
Okay.
So there's just an inside.
And what's left over?
Just B.
Just a b. So I'm erasing that, and I'm erasing that. Okay, what's the cube root of c to the 10th?
C to the third comes out. and C stays in.
Okay. So here's how I would officially write my answer. I would write it as a squared, b squared, c cubed times the cube root of bc.
Okay.
All of that there. And you didn't actually have to do it this way. You could have taken the cube root of the numerator, the cube root of the denominator, and then worked with them. But it's easier to simplify those first because it's relatively easy to do. You're just subtracting exponents. Number 11. Same base, different exponents. You're dividing the bases.
So 2 4/5, or 2 4/5 to the 4/5.
There you go. 2 to the 4/5 power. Okay. How about number 12?
Hmm.
12 is a little tricky. And the reason it's a little tricky is because you don't have the same base and you don't have the same exponent. So you can't immediately apply the rules of exponents. But there is something very in common between the numbers 25 and 5.
Right. So could you distribute the squared, or the 5 to the third, to make it 25 squared?
Well, except it's not. 5 cubed is not 25 squared. However, you're on the right track. And the reason you can't do it is because it's an odd exponent. If it was 5 to the 4th, yeah, that would be 25 squared. However, let's work with this one and see if we can put that in terms of 5. 25 squared is what in terms of 5?
Well, that would be 5 to the 4th, right?
Yeah, in other words, here's what I'm going to do. I'm going to take 25 squared, and I'm going to write it. I'm going to write the 25 as 5 squared in parentheses. And there's 5 squared, and that is 5 to the 4th. Okay, so now the problem is 5 to the 4th divided by 5 to the 3rd, all to the negative 3. Which one do I do first?
The 5 to the 4th and 5 to the 3rd.
Okay.
So that would be 5.
Okay.
So that would be then 5 to the negative 3rd.
Which is? It's the negative x.
Oh, you have to, so put it over. So 1 over 5 over 3, which is, 5 to the 3rd, which is 1 over 125, I think.
Yep.
Okay.
Okay, a similar thing here. Not really. Not really. I mean, you could make it into a similar thing. In other words, I can write 4 as 2 to some power, I can write 32 as 2 to some power, and I can write 16 as 2 to some power. But
Right.
I don't need to do that here. Why? Because my exponents are all the same. They're all 2/5. So all I got to do is multiply the two numbers and divide by that and make the whole thing to the 2/5 power, and there's my answer. So what's
Okay.
the answer?
So 4 times 32 is 128 over 16 divided by 16. So it's 8 to the 2/5.
Okay. And that really can't be simplified anymore. Incidentally, let me just make a comment because I don't really like the way you did that. If I'm doing this and I do it the way you did it, I got to use a calculator.
Okay.
But if I notice that 16 goes into 32 exactly 2 times, then I can divide the bottom and top by 16. Now the number is 4 times 2, which is 8.
To the 2/5. Okay.
My point is that always work with the smallest numbers possible. When I did the problem, I never dealt with a number greater than 32. When you did the problem, you dealt with 128 right off the get-go. And then you got to divide 128 by 16. That's hard to do by hand, so you have to pull out your calculator. But you should always reduce these, always. Never
Okay.
not reduce them. It eliminates the need for a calculator, typically, and there's no reason not to reduce them, even if you're using a calculator.
Okay.
So what's this one going to be?
So you can divide by 5. You can divide the top by 5. So that's 5 to the 3/4 times 25 to the 3/4. So
Hold on a second.
oh,
You don't divide both of them by 5. You only divide one of them by 5. So the answer is 5 times 125 to the 3/4. You divided both of them by 5. In other words, you divided that to get your 5, and then you divided that. Well, you can only do it once.
Okay.
You only divide it into one of them.
Okay.
So the answer is 625 to the 3/4.
Right.
Now, that actually can be simplified. Question is how do you know that? The key is always to know whether or not the fourth root of that number is a whole number. And in our case, it is. It's 5. So the answer is the fourth root of 625, which is 5, to the third power. 5 to the third power is 125. So that answer is 125 and should be taken all the way down to 125. In other words, you don't want to give that answer there. Now, the question is how do you know that when you see it? That is a perfect fourth number. Let me think about this for just a second. Because that's not a perfect fourth number, that's not a perfect fourth number, and that's not a perfect fourth number. So the only way you end up with a perfect fourth number is after you multiply all those together. then
Right.
you have a perfect fourth number. But recognizing that 625 is a perfect fourth number is not that easy.
Okay.
I mean, you can always, if you're allowed to use your calculator, I would go ahead and put it in, and if you get a whole number, that's the answer. If you get a decimal, then you want to leave it as 625 to the 3/4. In other words, you don't ever want a decimal answer here. Not
Okay.
to that. Not based on that right there. Okay? But if, like I said, if you have 625 to the 3/4, that's equal to 125. You could do that on your calculator if you wanted, and it should give you 125. It might give you 124.99999 or something like that.
Yeah, I did it, and it gave me 125.
Okay, good. It's always worth trying just to see, because you don't want to lose a point by leaving that as your answer.
Right.
Whereas you don't lose anything up here. If you leave this one as the fourth root of 3750, that's simplified. That can't be simplified any further. Whereas this one can be.
Okay.
Oh, wow. Sorry. I didn't mean to take us past your time.
No.
Dimitri, I will talk to you on Thursday at 4.
All right.
All right.
Thank you.
Bye-bye.
Bye.